Okay, so I'm assuming that that is that now recording. So, just going to go through these two questions that I was supposed to set for homework, but forgot to put them up on Frog. So yeah, apologies for that, I'm sure you're all gutted. I'm just going to go through it really quickly. So the question here, as you can see at the top, says that we've got a cuboid with volume 25 centimeters cubed, and we want to work out the surface area of the cuboid. So as we've been looking at, these are more complicated problems that require more steps for us to go through. So I'll break it down for you one step at a time. I'm going to start with finding x. Now I know at some point that I'm going to need to work out whatever the value of x is, so I might as well do that first. Go about it like this. First off, I'm going to need to use loads of different things, and you're going to need to make sure that you know all of these formulae and little bits of information that you need to solve this question. The first one is the volume of a prism. A cuboid is a rectangular prism. In this case, it has a square cross-section, and then it is 12 centimeters deep. So I know that the volume of it is going to be 12, the depth, times the area of the cross-section. Now the area of the cross-section is the length times the width, and in this case they're both x, so it's 12 times x times x. I will be using these little dots as multiplication symbols just so I'm not using crosses that might look like an x otherwise. So I then just put in the information that I know, so I know x times x is x squared. I know the volume is 25 centimeters cubed, and all I'm going to do is I'm going to rearrange this. So I know that if I divide both sides by 12, I get 25 over 12 is x squared. This here, this little equal sign with an arrowhead pointing towards the next bit is the mathematical symbol for implies. So if 25 over 12 is x squared, I know that x is the square root of 25 over 12. And again, we're doing exact calculations, so this is the answer. Okay, I don't need to get a rounded decimal or anything like that. It says in the question here exact, so here it is exactly. Next step, right, okay, so I'm going to have to try and figure out what the surface area is. Now for this, I'm going to find it out in terms of x first. It just looks a bit neater. I don't want to start sticking in all these all the time. So I'm going to draw the net out. Yeah, that's right, this is what dropping out in year 9 looks like. So we've got the net of our cuboid. We've got 4 rectangles which are all the same. Now usually when you have a net of a cuboid you get 3 pairs of faces. We effectively still do it, it's just 2 of our pairs effectively are exactly the same. These 4 faces, the 4 long faces, are all the same. So we have 4 lots of these, and then we've got 2 short ones at the sides, the wings if you will. And I've roughly colour coded them. The big faces are green, the short faces are purple. So I've got the area of one of these green rectangles is going to be length times width, that's 12 times x. The area of one rectangle is 12x. Therefore the area of 4 rectangles is our 48x here. This 2x squared, well the area of one of these short wings, one of the purple squares, is x times x, so it's x squared. There are 2 of them, so it's 2x squared, and therefore the total area covered by these 6 faces is 48x, that's the 4 long rectangles, plus 2x. They are the 2 shorter squares, the 2 purple ones. So I know that is the surface area in terms of x and x squared. My last step is just to substitute in the known values, the values that I worked out here for that. So we've got 48 times root 25 over 12, and we've got 2 times 25 over 12. X squared is 25 over 12, so I just put that in there. I'm not going to simplify the left hand side. We haven't actually looked at that yet, so this side stays the same, and I just know that 2 times 25 over 12 is 50 over 12, and that is your answer. Don't forget your units, centimeters squared. But this is your answer. I know that it must look pretty horrible, but trust me, it's all good. This is what it should be. On the next page, spoilers. This is the question. So this one is much harder, I think, than question 6, and I will try and walk you through it step by step. An orange has diameter 12 centimeters. Once peeled, its volume is 500 pi over 3 centimeters cubed. How thick was the skin? There you get to see yet more artistic brilliance. So this is my awfully rough diagram of what my orange looks like. As you know, most oranges are red and purple. So the radius I've drawn on here, I've not drawn the diameter of 12 because I know that I'm not going to need the diameter when it's looking for volume. Okay, the volume is on the radius. Now this is a formula that you might not be so familiar with. That is the volume of a sphere is 4/3 pi times the radius cubed. If you don't know this, there is a good chance that you'll need to remember it for your GCSE. I don't know if it's given to you. I think so, but I'm not certain. If the diameter is 12, I know the radius is 6. Okay, you do need to know this off by heart. The radius is half of the diameter, and vice versa. The diameter is twice the radius. We're going to be using the radius because we're looking at volume. So the first thing we need to do is work out the volume of the whole orange, including the peel. So to do that, we're just going to use the information we've got. The radius is 6. 6 cubed is 216, so I just substitute r for 6. 6 cubed 216, so this is the next step, and I get an answer of 864 pi over 3. Now that does actually simplify, but I'm going to leave it as a fraction over 3 because my next step therefore is to work out the volume of the peel. So this is the volume of the whole orange. The next step is to work out the volume of the peel because I want to know how thick the peel was, and the only information I can get so far is the volume of it. So to do that, we take the volume of the whole orange, which is this value here. We're going to take it away from the volume of the inside, the fleshy bit if you will, 500 pi over 3, and what's left must therefore be the volume of the peel. If you look at Da Vinci's painting up here, you'll see that the red bit here is the peel, the purple bit here must be the inside. Altogether we've got the whole orange. If we take out the purple inside, what we must be left with is this red peel. So this volume here is the volume of our peel. This doesn't actually simplify exactly, so I am going to leave it in that form. It is 364 pi over 3. So this is, in my opinion, the hardest thing I think we've done all year, and it is how do I use this information to work out the thickness of the peel. And that is actually by using this formula again, except we're going to reverse it. Whereas before we were given all the information we needed to find out the volume, here we're giving all the information except for the radius, and we're going to use it to find out that. In this case, for the red thing, the radius is going to be the distance from the outside of the peel to effectively the inside of the peel. It's going to be the thickness of our peel, and it is repeated rearranging basically. I'm going to times both sides by 3. Okay, that gets rid of the denominator at the bottom of both fractions. I am then going to divide both sides by pi, so this pi cancels off here and here. I am then going to divide both sides by 4, which gets me that 91 is r cubed. Now you do need to know your cube numbers up to 5 cubed. Your cube numbers are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Now as you'll see, 91 is not one of those numbers that I have listed, so I don't know what the cube root of 91 is, because remember, so the inverse basically of cubing something is to cube root, and in this case, therefore, my answer is going to be the cube root of 91, written as it's the square root sign but with a little 3 above it. So what I've got here is my answer. So the thickness of this peel is the cube root of 91, which is, I don't know actually, not entirely sure. It's quite thick anyway, but that's fine, because that thickness is going to be the whole way across, so I don't know, it's like maybe 2 centimeters altogether. It's 4 centimeters here and here. I guess this little distance here is 2-ish. Seems about reasonable. So yeah, that's it. That's how you would solve a question, or questions like this. If the recording is a little bit sketchy, I will try to re-record it, but this is what I'm going to show you guys, well, on Wednesday's lesson 5, so hopefully it will work quite well. And it will also be up on our frog site. Although, actually, if you're seeing this the second time, it will already be on frog, so I don't know what I'm telling you. Alright.